Okay, number 3 is asking us a water balloon is catapulted into the air from the top of a building. The height hx in meters of the balloon after t seconds is h of x at -5t squared plus 30t plus 10. What are the domain and range of this function? When will the ball hit the height, reach a height, of 30 centimeters? So this is a two-part question. So let me write this down first. So I'm gonna, the A is asking us domain and range, right? Domain and range. And then B is asking us time at height equals 30 centimeters. I'm using h here as height here. So now let's do the domain and range first. So I'm given the function here. We're given the function h at x equals -5t squared plus 30t plus 10 here. And we're looking at what is the domain and range. Well, if you look at the domain range, I'm taking a look at this function here. What we can do is we can solve for it either graphically or we could solve for it algebraically. In this case, we'll probably do an algebraic one, just because, again, I could graph this as well using Desmos or something like that, or I could basically solve for the intercepts and also the graph, right? So let's solve for this here algebraically. So again, if I have h of x here, what I can do is I can take out this -5. I'm going to common factor first to get t squared minus 6t minus 6. And then all I'm left here with, I know here by inspection, t squared minus t minus 6 here, I can factor by inspection here, and this will get me, let's see, 6 times 1. Let me see if this is factorable. I'm pretty sure that this here is factorable. 1 minus 6 here would give me, I would have to actually use quadratic formula to give me the intercepts here, because it's actually not factorable. I thought this was a 5 here, so it's not factorable here. So what I can do here is I can use a quadratic formula to solve for this, to solve for the x intercepts here, but that might take a lot of time. So let me just, I think for the sake of time, what I'm going to do is I'm going to actually show you a graph of this function here without, and then kind of do that. So let me just skip the steps for the quadratic formula. I'm pretty sure you folks at home know how to use the quadratic formula already. And basically you get here x minus 6.873, and then you get here x plus 0.873 here. So you get these two x intercepts, and again, I rounded here. So what we can do is we can actually, we can use these intercepts to kind of like graph this, right? So we can graph this, or maybe sketch a graph here. So we can sketch a graph here. And we can say that, again, this is y, this is x here. And we know that x intercepts here, we have our 6.873 here. So I'm going to say this here is 6.873. And then we have also a graph. Here it's 0.873, and we know that our parabola is going to open. It's going to open upwards, right? I have a negative a value here, so it's going to open. Basically, it's going to do something like this. So this here is our sketch. Again, we can also solve for the vertex here very easily by simply just taking the equation of the axis here, so dividing these two guys by 2, and then substituting it into the equation. So let me just do that for you to solve for the vertex here, right? So again, I have 6.873. I'm going to add that by add that to negative 0.873 to get, again, a value of 6. I divide it by 2 here. It's going to be 3. So therefore, at 3 here is going to be my vertex, right? So I'm going to plug h of x at h of 3 here to solve for the height. So -5 times 3 squared plus 30 times 3 plus 10 here would give me a value of 855. So this here would be 855. And this here would be the vertex of my parabola. So understanding this, and we solve for this, and what we can do is we can actually, let me just use Desmos to verify this for you. And what we can do is, once we get this graph here, we can solve for the domain and range, right? So let me write here, this is -5. I'm going to write x squared instead, and then plus 30t plus 10t here, or sorry, x, not t, plus 30t plus 10x here. And as you can see, our parabola looks something like this, right? It is very, very, very large here, and it's going to span to about 80. Oh, I don't know why it's 855 here. This is not 855 here. The vertex here, I think I might have done my math here incorrectly. 4 and 80. Oh, yes, it's actually 4 and 80. Sorry, not 3 and 80 here. I think I messed up my math here. I'm supposed to add both guys here. So sorry, it's 6.873 plus 0.873 here, which will give me a value of about 7.876 here. So let me just check my x-intercepts for us here. -5, sorry, -5. So here I have negative. Okay, sorry. Oh, so I think I graphed this wrong. Sorry. So I'm gonna write here because I'm graphing this guy here, right? So this is t squared here times -6t. Oh, this is a 10, not a 6. Oh my gosh, I'm all over the place today. This here's a 2. Sorry, folks. I don't know why I wrote a 10 here. Okay, so this graph is wrong. Oh no, my fault, guys. I'm off my game today, but that's okay. So basically what I have to do here is, again, I have t, yes, here, I have -5. So -5, I factor that out, I get -5 times t squared minus 6t minus 2, right? So 1, -6, -2. I can factor that, I get 6.3. So if I were to factor that, I would get t would be 6.317, and this here is positive 0.317 here. So again, this is simply just done through quadratic formula, and the -5 is here. And again, I can always graph this, and I would basically get the graph that I saw at Desmos. So let me just write that for you here. 5x squared plus 30t plus 10, right? Yeah, plus 30x plus 10x plus 10 here. So again, you get two x-intercepts here. You get one here at 6.317, like I said here, 6.317, and then one at 0.317. And again, what I can do is find the vertex here simply by adding these two numbers and finding the average of these two numbers, right? So I can say here 6.317 minus 0.317 here is going to give me 6. And then I'm going to divide that by 2 to get me our vertex here, which is going to be at 0.3, right? It's going to give me my 3 here, right? So again, I'm using the equation of the axes to basically finding the average, right? 6.317 plus negative 0.317 divided by 2. This is 6 divided by 2, which equals 3. And then I can basically substitute in h at 3, right? I can say h at 3 would equal -5 3 squared plus 30 times 3 plus 10. This here would equal -5 times 9 plus 30 times 3 is 90 plus 10. This here is -45 plus 90 plus 10 here, which is simply -90, which is, let's see, -45 plus 90 plus 10 here would give me a value of 55 here. And 55 here is the vertex, right? As solved here as well. So once we're given the vertex here, why do we care about this vertex? Well, we care about this because we're finding the domain and range, right? So we care about this because we want the domain and range. So let me do the domain first. So domain here is indicated by the x here equals all real numbers. And this is just a notation that we write here. X belongs to a set of real numbers, and the x here, if you take a look at this x here is going to be all real numbers, right? Again, I can extend this all the way to here, -35 or something. I'm still going to get some type of value. I can extend into positive infinity here. I'm going to get some y value here. So I can say x belongs to a set of real numbers. And there's no restriction on this x here, right? So this is it. But the range here, again, y belongs to a set of real numbers. And y here, again, I have this vertex here. This vertex is so important because above this vertex, I don't have the function anymore. So this function has to be, y has to be either at 55 or lower or below 55, right? So you can say here, y has to be either less than or equal to 55. So this here is my domain range for this function here. So that was part A. And then part B was asking, when will a ball reach a height of 30 centimeters? So again, because this is in meters, right? So we actually have to convert 30 centimeters into meters first. So 30 centimeters is going to equal, if I want to convert this into meters, so 1 meter is 100 centimeters. These centimeters cancel out, so 30 divided by 100 is simply 0.3 meters here. So I'm going to get h at h basically is height, so which is going to be at 0.3 here, equals negative 5t squared plus 30t plus 10 here. And then I can simply move 0.3 to the other side, so 0 equals negative 5t squared plus 30t, and then moving that to the other side would give me positive 9.7 here. And what we can do here is we would basically have to do quadratic formula. I don't think I can factor this out. So again, for the sake of time, I'm going to actually I'm going to show you what the answer is, but you can write down basically t here equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative here 30 here is negative 30, negative b here is negative 30, plus or minus b squared here is 900, minus 4 times negative 5 times 9.7 here. Again, I'm kind of speeding through this just because, just for the sake of time here, but yeah, I'm pretty sure we know how to use the quadratic formula. Plus or minus, again, the square root here would be 900 minus 4 times this is negative 5 times 9.7. This here would give me a value of 1094 all over 2 times negative 5 here is negative 10. So therefore, I'm going to get two answers here. Negative 30 times the square root of 1094 divided by negative 10. And this here is negative 30 minus the square root of 1094 here. Square root of 1094 divided by negative 10. So these two here are my answers for the t values here. And then basically I'm going to sub this into my calculator to solve for something. And usually one of these guys here is going to be negative. And then again, I can't have a negative time. So I'm basically just going to cross out that answer and basically take the other one here. So again, this here is my negative answer. I get negative 0.307. And this would be in seconds. And this here, I would get a value, I should get a positive value here of 6.307 seconds. And again, because I can't have a negative time here, I can say that I can reject this answer. T has to be greater or equal to 0. So therefore, 6.3 or 6.3 seconds here is my answer. And if you look at here our graph here, we can take a look at where 6.3 is and figure out where it is at 30 centimeters, right? So if I'm looking at the graph here, I'm looking at where is this graph 0.3. So let's see, 0.3 would be either 0.3 would be either at this point here. This point looks like 0.3, so again, this was the negative 0.37, or it would be all the way here, right? 0.3 would be about here. Again, 6.37 here, which is about 6.3 seconds here. So this solution obviously is incorrect. They didn't show me any work here. And I'm going to write down here domain of function here is x belongs to a set of real numbers. There's no restrictions on my x. Range of function is y belongs to a set of real numbers as well. And y had to be, let me just look at my answer here. Y had to be greater, or y had to be less than, or y is less than or equal to 55. And then finally, the ball will reach a height of 30 cm at 6.3 seconds. So this is incorrect because it is an incomplete solution. Okay, solution here is incorrect. Okay.